In this video, I'm going to be showing you how you can create a NeoPixel LED strip chase effect using Arduino block coding with CodeKit. The effect is going to be just like the one you see on the screen right now, and you can get started with CodeKit for free on the web at edukits.co/code, or you can click the link in the video description. Now let's get started with wiring, which is pretty simple for this one. All you need to do is connect ground and 5 volts to the LED strip, and then connect its signal line to pin number 8 on the Arduino board. Now we can jump into coding with CodeKit. The first thing we want to do is set up our RGB LED strip. In CodeKit, let's start with a new document, and over here on the sidebar with all of our block categories, let's open the color category. We have this attach lights on pin block, which I'm going to drag under our start block. Here we need to supply the number of LEDs, which in our case is 4, and the pin number that they're connected to, which in our case is 8. Now that we have the LED strip set up, we can start to manipulate pixel colors and send over data to the LED strip. To show you a quick demo, I'm going to drag this set light block and just upload the code really quickly. I'm using CodeKit Pro, so we have an option in CodeKit where you can upload in one click from the web, no install required. But if you're using the Arduino IDE, you can just copy that code to your clipboard and upload. So the code's uploaded, and you can see that our first LED, which is LED 0, is set to purple. And that's a little quirk here with counting in Arduino and a lot of coding. We start counting at 0, not 1. So the first LED is 0, the second LED is 1, and so on. So now you can see how we basically attach the LED strip and we can set a particular color on that strip. If you want to set the color over, you can duplicate that block, set the light to 1, and then upload that. We can change the color there as well to keep things interesting. So with this, we should have the first LED as purple and the second one as red. So this gives you a little bit of an idea over how this is going to work. The next thing we want to do is to create the chase effect. So the chase effect, as you saw in the very start when we shared the demo, is one LED being lit up at a time, and we move through the entire strip, which changes which LED is lit and which is not. The key idea here is that at any one time, we have only a single LED that's lit, and all of the rest we've turned off, which we should do beforehand. So those are the two things we need to do. We need to turn all the LEDs off and then turn a specific LED on. And we're going to do that using a loop. So under the forever block, which allows us to repeat code over and over again, because we want this looping pattern, I'm going to grab this loop block, and it's going to be a special count loop block. I'm going to put this under forever. We can now get rid of the extra set light block, and we can move this block, the remaining one, under the count. So what this count is going to do is repeat the code inside here from 1 to 10, and it's going to count with this special variable I. If I right-click on the count block and we create get I can drag this over here into the specific light that we're doing. So what this means is that we're going to start with I being equal to 1, so we set light 1 to purple. This is going to increase by 1, and then we set light 2 to purple. This is going to increase to 3, and we'll set light 3 to purple, and it will go all the way up to number 10. So that's how this count block works. If you remember from before, though, we said that the first LED is 0. That's how we start counting there. So we're going to need to start at 0. And we could type in the number of LEDs we have here, but it might be useful to create a variable because we're going to need to do another loop just like this in a second. So under the variables tab, I can create a new integer, which is a whole number, to store the number of number of LEDs that we have in our strip. Then under the setup, I can set this to be 4, which is what we have. And then the variables flyout gives us an option where we can reference that number elsewhere in our code. So in the setup, we can attach this number of LEDs here. And then under our count block, we can count from 0 to the number of LEDs. The last thing we need to do here, though, is add a quick subtraction block, because because we start counting at 0, the last LED is actually the number of LEDs minus 1. So now we're going to loop through all of the LEDs and turn them on. Because we want a little bit of a delay between the different states, we can go under control and let's add a quick delay block. There are 1000 milliseconds in a second, so doing a delay of about 250 milliseconds is probably a good value here. So I've clicked upload, and you're going to see that the LEDs go from left to right. And I'm going to reset that for you right now. You'll see again, they go from left to right, but they don't chase. And that's because we need to turn all of the LEDs off. We need to turn all of the LEDs off before we highlight our specific LED pixel. So this is going to require another loop, and for that I'm going to actually create a special function to make this easier to follow. So under functions, we can create a new function, and I'm going to type in turn off all LEDs and click save. This special function creates a new custom block for us that we can put in our code. So under functions, we now have this block that says turn off all LEDs. And when we run this block, it's going to run all the code inside here. So I'm going to leave that here for just a second and duplicate this loop that runs through all of our LEDs, as we've just seen. What I'm going to do now is delete this little delay so that it happens instantly. And I'm going to change the light color from purple to black, which means that we're actually turning all these LEDs off. And then finally, I'm going to drag this turn off all LEDs and put it into the step right before we highlight our target LED. So what's happening here is that every time in our loop, for each specific LED in the strip, we're going to turn off all the LEDs. We're going to set that specific LED, our target one, to purple. We're going to wait 250 milliseconds and then move on to the next LED. Because we turn off all the LEDs, and then we turn on a single LED, that means there's just going to be one lit at a single time, not the whole strip like it happens here, because with the last code we sent, we never actually turned any LEDs off. I've clicked upload on that code, and you should now see a nice little chase effect going on. The final flourish I'm going to add here for us is generating a random color to use for the LEDs. For the LED that we're highlighting. Under the color category, we have this specific color block where we can set the red, green, and blue values. And because we're about to drag a big block in here, I'm going to right click and select external inputs, which puts each of those on their own line. Then under the mathematics category, let's grab a random integer block, and we're going to go from 0 to 255, which is the range for the colors. So each red, green, and blue value is in that range. So this means that we're just picking a color at complete random. I've duplicated that 2 more times so that each of our red, green, and blue values are fully random. And then when we upload this, you're going to notice that we now have each LED pixel picking a different color every time it runs. So there you have it. That's how to set up a NeoPixel chase effect using Arduino block coding right here in CodeKit. If you want to have a play around, there are heaps more blocks over here in this color category. And we also have stuff like input outputs, sensors, and motors, servos, and the like that you can connect to make really cool projects. If you've enjoyed this video, please subscribe to our channel because we have heaps more like it that you will really enjoy. The link to CodeKit is in the video description, and it's free to get started on the web.